Okay, so it should be recording now. Oh, cool. Okay. All right, cool. So give me about a minute or two to get set up on my end, and then we'll get started. So can I stop the video? I don't think so. Let me see. Can you hear me, guys? Perfect. Okay. All right, so let's get started. So we're going to go through the Test 3, Exam 3 review. And so what I'm actually going to do is I'm going to be toggling back and forth between the actual review. So I have a version of the review here. And then I have the screen where I'll be doing the writing, which would be my Paint application. Because I want to kind of make sure you guys are good with entering answers, because you got to use square roots and, rational expressions. So for the questions that I think, it would be helpful to see how to input the answers, I'll come over into the screen and we'll actually type the answers in. Might not do that every time, but we'll see. And I'm going to just kind of toggle back and forth. Actually, oh, this wasn't a good idea. I wish I could just write on this screen, but I don't think this pen is good. Let me try it. Let's see here. Because I normally use the YouTube deal, but my colleague, who is the brains behind the technical part of that, we weren't able to get together this time around. So, but this is what I use for my other classes, so I know that it works. Now let me see if I can write on this. I just don't think it writes well. It's okay. I don't know that. It's good for simple stuff, but let me see. Excuse me. And because it is the springtime, every time I do reviews, I have allergies. So that just, gives the video more flavor. So, okay, I'm not going to write on this part because I don't like how it looks. And I already don't have the best handwriting in the world. So I'm just going to write them on the side and then include them later. Okay, so let's get started. All right, let me get off the pen mode. Okay. So I don't want that there. Make that go away. Okay. All right, so let's get started. Number 1, we are looking at finding, so this is number 1. Let me make sure you can see that. Let me get a preview screen. Hold on one sec, guys. Okay. Good. Thank you, Karen. Okay, so number 1, find all the numbers for which the rational expression is undefined. If the rational expression is defined for all real numbers, so state. So we have 13 over 4x minus 24. So you have to take the denominator and set it equal to 0 to figure out what numbers to exclude from the domain or restrict. So we take 4x minus 24 and set it equal to 0. We're going to solve for x, and those are the values we're going to exclude. So if we add 24 to both sides, then we have 4x equals 24. Why am I writing so big? Then divide by 4 to solve for x. So I'm going to have x equals 24 divided by 4 is 6. This is the value that we're going to exclude from the domain. So to answer the question here, the expression is undefined when x equals 6. All right. And that's going to be our answer. Okay. Let's look at number 2. So number 2, we're going to simplify the rational expression. So we have y squared minus y minus 6 divided by 3 minus y. Okay. So we're going to factor the top. So we have a trinomial, so we're going to start with our parentheses. The leading coefficient is a 1, so we can go ahead and just start with y and y. So now we need two numbers that will multiply to give me 6 and subtract, because 6 is negative, to get this coefficient of 1. And I kind of skipped a step because, so the way that I factor trinomials, I use what's called sign rules to start setting it up. So to get the first sign here in the first binomial, I take the first sign in the trinomial. So since this is negative, this sign will be negative. And then to get the next sign in the second binomial, I multiply the two signs in the trinomial. So negative times negative is positive, so this sign is going to be positive. And so now, let me go back to what I was saying. So I need two numbers that will multiply to give me 6, but subtract, because 6 is negative, to give me 1. So that would be 3 and 2. And if I'm going to use these sign rules, I'm going to always put the bigger factor first. So 3 and then 2. So that's kind of like a trick for factoring trinomials, is to use those sign rules. But again, we know we have the right factors because negative 3 times 2 is negative 6, and then negative 3 plus 2 is negative 1. So however you factor is fine, but long story short, we're going to factor the top. Okay, so now we have that over 3 minus y. So right now it looks like we have factors that we can cancel out, but we don't have that quite yet. So if we look up here, and then look down here, they're almost the same, but y is positive at the top and y is negative on the bottom. And 3 is negative at the top and 3 is positive in the bottom. So what we want to do, if we factor out a negative in the bottom, that basically changes the sign. So then instead of saying 3 minus y, it'll be negative 3 plus y. So we factored out a negative 1. And the reason why we did that is because now we have common factors we can cancel out. So now if you look here, in y minus 3, y is positive, 3 is negative, negative 3 plus y, y is positive, 3 is negative. So you can actually cancel those out. And so now we just have y plus 2 divided by negative 1. But that's not how you want to enter that answer. Let's simplify that. So if we divide y plus 2 divided by negative 1, that basically changes the sign. That's going to be negative y minus 2. So that's going to be your final answer. All right? So you're probably definitely going to see a problem like that. So don't just assume that because you see y minus 3, 3 minus y, oh, that's the same. It's not the same. They're actually different signs. So they're not common factors yet. But if you factor out that negative 1 that I haven't read, then you get common factors you can cancel out. All right? Okay. Let's go with number 3. Okay. Now I realize that they don't let me move on. I'm just going to put an answer. It's going to be wrong, but I don't want to type this every time. I don't want to keep y'all all day. Let me put the keyboard back on here. I can type it a little faster. Okay. All right, check the answer. Yay. Okay. Number 3. Okay, give me a sec to write that down. You guys can write that down too if you're working with me. Okay. I'm going to write it again. So if you haven't written it, I'm going to write it again. Okay, so number 3, we have y squared plus 6y plus 5 divided by y squared plus 11y plus 30, all that divided by y squared minus 11y plus 28 divided by y squared plus 2y minus 24. Okay, so we are dividing rational expressions. So in order to divide rational expressions, I have to multiply by the reciprocal, or do what I call keep, change, and flip. So what that means is that we're going to keep the first rational exactly as it is, y squared plus 6y plus 5 divided by y squared plus 11y plus 30. We're going to change division into multiplication, and then we're going to flip the second rational by just flipping what's in the bottom to the top, and what's at the top, put it in the bottom. So we have y squared plus 2y minus 24 at the top divided by y squared minus 11y plus 28 in the bottom. Okay, so now we are multiplying straight across. Before you just start multiplying, let's factor everywhere and then check for common factors to cancel out. So let's start with the first one. So we had all these are trinomials, and they all have a leading coefficient of 1, so we can factor them all the same way. So I'm going to start with the top, the numerator in the first rational. So I'm going to have y, and they're both going to be plus. So I need two numbers that multiply to give me 5 and add to give me 6. And that would be 5 and 1. Okay? Let's look at the bottom. So same setup. This will also be y, and this will also be positive. So I need two numbers that multiply to give me 30 and then add to give me 11. And that would be 5 and 6. All right, times. Let's look at the numerator in the second rational. This will also be y times y. But now here, let's pay attention. The first sign is plus, so that means this sign will be plus. And the second binomial sign depends on what the two signs multiplied together are. So positive times negative is a negative, so this will be negative. So now I need two numbers that multiply to give me 24, but subtract, because 24 is negative, to give me 2. So two numbers that multiply to give me 24 and subtract to give me 2. And that would be 6 and 4. 6 times 4 is 24. 6 minus 4 is 2. Now, you want to put the larger factor first. 6 and 4. Okay, now let's do the denominator in the second rational. So I'm going to set that up. Y and y. So now let's pay attention to the signs. The first sign is negative, so this sign is going to be negative. Then the next sign, the next binomial, is going to be based on multiplying the two signs in the trinomial. So negative times a positive is a negative, so this will be negative. And so we need two numbers that will multiply to give me 28 and add, because 28 is positive, to give me 11. That's going to be 7 and 4. And here it doesn't really matter which one we put first because they're both negative, but I like to try to stay consistent. Okay, now that we've factored everywhere, now we can just easily find common factors in the top and the bottom. So let's see. We have y plus 5 at the top. There's a y plus 5 at the bottom, so we can cancel that out. There's a y plus 1 at the top. There are no y plus 1s in the bottom. Here's a y plus 6, y plus 6, and then y minus 4, y minus 4. So whatever's remaining is going to be what's left over. So in the numerator, we just have y plus 1. We don't need the parentheses since it's not being multiplied by anything else. In the denominator, we have y minus 7. All right? And then that's going to be our final answer. Y plus 1 over y minus 7. Okay, so let's see. So you can use this button here. Can y'all see that? It looks small on my preview screen. Maybe it's okay. I'll make it a little bigger. Okay. What did I say the answer was? Okay. Y plus 1, y minus 7. Y plus 1 over y minus 7. Check your answer. And yay, we are correct. Okay. Number 4. Okay, number 4, we have 3y minus 2 divided by y squared minus 9 plus 3y minus 2 divided by 9 minus y squared. Okay, so we are adding rational expressions. So in order to add or subtract rationals or fractions, same idea because they're the same thing, you must have the same denominator. Okay, so here we almost have the same denominator, but not quite. This is y squared minus 9 in the first rational. The second is 9 minus y squared. So remember, the sign goes with, the sign in front of the term goes with that term. So this is a positive y squared in the first expression. That's a negative y squared in the second. So we're going to do the same thing that we did in, I think, problem problems ago. Let's factor out a negative somewhere. In one of them, it doesn't really matter. I don't know. Let's do the first one. So if we factor out a negative in the bottom, then what's going to happen, that's going to change all of the signs. That's going to be negative y squared plus 9. Let's do that in one of them to try to get the same denominator. Okay, so now let's look at these new denominators. So, let me see here. Okay, so let's put the negative at the top so that we can clearly see those same denominators. So let's take this negative and apply it to the top just so we can see the denominators better. So that's going to be negative 3y plus 2 over negative y squared plus 9. Okay, so now we have those same denominators. So now we can combine the top, negative 3y plus 2 plus 3y minus 2 over, let's see, negative y squared plus 9. Something is weird. What did I do wrong? I don't want 0 in the top. Y squared minus 2. Okay. Maybe I'm multiplying the top and bottom by a negative. That's what I'm really doing. So that becomes negative 3y plus 2. And this will be negative y squared plus 9. I don't like this. That would be 0. Let me see. Negative 3y plus 3y is 0. I don't like this, guys. Let me... We're alive, people. Hold on. Let me see. I don't like how that's going to look. That doesn't look right to me. Oh, okay. Don't second guess yourself. Okay, so alright, we were okay. It just looked weird. Okay, let's go back here. Yeah. Okay, so we were okay. I'm just thinking we weren't, but we were fine. So to summarize, we were trying to get the same denominator. In order to get the same denominator, if we multiply one of the denominators by a negative 1, that will create equal denominators, but we want to multiply it to the top and the bottom. So we've got negative 3y plus 2 at the top in the first rational, and then negative y squared plus 9 in the bottom in the first rational, and the second one stayed the same. So now that we have the same denominators, and it doesn't matter which one of these we wrote because they're the same. I just wrote the first one down. So then when we combine the top, we've got negative 3y plus 2 plus 3y minus 2. Now when we combine like terms, negative 3y plus 3y cancels out. 2 minus 2 actually cancels out as well, so the numerator is actually 0 over negative y squared plus 9, or 9 minus y squared. And 0 divided by this expression is going to actually equal just 0. So the answer here is just 0. But maybe, let's say this problem was exactly the same, but like, I don't know, this number was different. It was like -5 or something like that. Then you wouldn't have 0 in the top. You would have like a number. So it just so happens that the numerator is 0 here, but that's not necessarily always going to be the case. Okay, so the answer for this one, simplified, is just 0. Okay. Okay, here's number 5. Oh, you know what I could do? I can make this smaller and do it on the same page. Haha. That's a little better. Okay. Let me make sure you can see what I'm doing. Okay, good. Okay, so we've got 9x plus 20 over x squared minus 16 minus x plus 5 over x minus 4. Okay, so same type of thing. We are subtracting rationals. We have to have the same denominator, and we don't right now. And it's not going to be just so simple to multiply by a negative, sorry about that, to get the same denominator. But we can factor to see what our factors are, and so we can try to get the least common multiple between, or least common denominator between both denominators. Let's factor x squared minus 16. This is difference of two squares. So that's going to be x plus 4 times x minus 4. And then we can't factor x minus 4. So the least common denominator needs to have all of the factors accounted for. So we definitely need an x plus 4 in our least common denominator. And we need an x minus 4. So if this denominator will take care of both the first denominator and the second denominator. So now you look at these denominators and figure out what are we missing to make them both look like our least common denominator. Well, the first one is the least common denominator. So this second rational needs x plus 4. So we're going to multiply it by x plus 4 so it can look like the LCD. But we can't just multiply the bottom by x plus 4. We have to also do it to the top. Okay? All right, so this first one's going to stay the same. 9x plus 20 over x plus 4 times x minus 4 minus, now we have x plus 5 times x plus 4 divided by that same denominator that we got. All right. Okay, so now we have the same denominator. So let's just write that. X plus 4 times x minus 4. And now here we're going to write the first numerator, 9x plus 20, minus, and now let's distribute x plus 5 times x minus 4. That's going to be in parentheses because it's going to be, we're subtracting all of that. So x times x is x squared. X times 4 is 4x. 5 times x is 5x, so this will be plus 9x. And then 5 times 4 is 20. Okay, so now 9x plus 20. Now we are ready to distribute this negative. Minus x squared minus 9x minus 20. All of that divided by that LCD, x plus 4 times x minus 4. So now let's combine like terms. So we're going to have, we have negative x squared that can't be with anyone else. And then 9x minus 9x cancels out. 20 minus 20 cancels out. So we have negative x squared over x plus 4 times x minus 4. All right. So now let's look at how we would put that as our answer. Okay. Oh, it's not going to let us keep it there. Okay, so negative x squared. So negative x squared, actually use the caret symbol to do that from the keyboard. And so if you highlight everything, then you press divide, it'll automatically make it be a numerator. So now what's my denominator? Okay, x plus 4, x minus 4. So now I'm going to type x plus 4, x minus 4. And you could have typed that in the other way, and you would have been okay. And we have the right answer. Yay, it's always a good feeling. Okie doke. So now we have a complex rational expression. So this is number 6. 6 plus 1 over x. All of that divided by 8 minus 1 over x. Okay, so to simplify a complex fraction, let's find the least common denominator of all the denominators. And the great thing about this one, the only denominator we have is x, and then 6 and 1 are over 1, so the LCD is just x. So what you want to do is multiply the entire numerator by x and the entire denominator by x. This is what that will actually look like. That's going to be 6 times x plus 1 over x times x divided by 8 times x minus 1 over x times x. So we multiply everything by that least common denominator. Okay, so what's happening now? 6 times x is 6x. 1 over x times x, those x's actually cancel and we'll just have plus 1 over 8 times x is 8x. And then here again the x's cancel and then we just have minus 1 left over. And we can't simplify this further, so the final answer is just 6x plus 1 over 8x minus 1. 6x plus 1 over 8x minus 1. Check your answer. Here we go. It helps to check your answer before you, well, I don't know. Does it give you a new problem? I'm not sure. But check your answer and you can move forward once you get that right answer. Okay, so now we're going to solve a rational equation. So we have not solved an equation so far. We've just been simplifying rationals. Now we're going to actually solve the rational equation. So we have x plus 4 over x equals 13 over x. Okay, so the best way to solve these is to clear out the fractions. And the way that you do that is that you multiply the entire equation by the least common denominator. Looks like I have some questions. Let me check that. Oh, you can't check your answers? Okay, I see that y'all don't have the option to check your answers. I'll have to check on that because I don't mind that feature. So I'll check on that when this finishes. Thank you. Check your answers. Okay, I'll do that, guys. Thanks for letting me know that. Because I wouldn't mind you having that option for the review. Okay, so that's why these things are so helpful. Okay, so now, again, we're going to clear out the fractions. So you want to multiply the entire equation by the least common denominator. And we got lucky here again. The least common denominator is just the only denominator that we see, and that's x. So we're going to multiply everything by x. That looks bad. Let me write that on the other side. Whoa. I didn't want to do that. Okay. X. All right, so x times x is x squared. 4x over x, the x's cancel. And we just have plus 4. And then here, the x's cancel as well. And we'll just have 13. I did not want the to be blue, but that's okay. All right, so now we have x squared plus 4 equals 13. So, I don't want blue. It shouldn't matter, but it does. Okay. All right. Oh my gosh. Okay. Oh my gosh. Oh my gosh. I'm going crazy. Okay, I'm going to lose my mind. Plus 4 equals 13. Okie dokie. So now we are going to solve for x. So we need to subtract 4. What is wrong with me, guys? Okay, subtract 4. So we have x squared equals 9. And I think I'm jumping ahead. I don't know if you've learned how to solve like this. I'll keep going by maybe skipping units. Okay, so x squared equals 9. To solve for x, we can take the square root of both sides. Thank you, Karen. Okay, so let me go back here. Okay, let me go back here. You can solve this way. This is okay. But let me just stick with where y'all are. You're going to learn this next module. So we had x squared plus 4 equals 13. Okay, we're solving for x, so we need to set it equal to 0. So in order to set it equal to 0, let's subtract 13. So then we have x squared minus 9 equals 0. And then to solve this equation, we'll factor. So that's going to be x plus 3 times x minus 3 equals 0. And so now that you have factored, we're going to use the zero product property and set each factor equal to 0. And so when I solve each one for x, if I subtract 3 to solve for x, I'll have x equals negative 3. And if I add 3 to solve for x over here, I'll have x equals positive 3. So I actually have two different solutions for this particular problem. Okay? Just to let you know what I was doing, which you're going to learn after this test, is that you could have solved at this point, x squared equals 9, by taking the square root of both sides. But when you take the square root, when you're solving an equation, the answer is plus or minus whatever your square root is, and that would give you x equals plus or minus 3. But we haven't learned that directly yet, so the purple will probably be the way that makes more sense for you at this point. Okay, so the answer will be 3 and negative 3, or negative 3 and 3. I don't think MyMathLab is picky about how you enter it. And that's what they say the solution set is, so it's saying it's a set of numbers possibly. If you were to plug in those numbers and you ever had 0 in the denominator and it made it undefined, then and you had no solution, you could say the solution set is no numbers, no real numbers. But negative 3, comma 3 would be your answer. So we're good to go. Okay, so solve the given formula for the specified variable. Okay. Whoa, where'd my work go? Sorry, my computer just went to sleep. Okay, so he's back up now. So we've got 1 over r plus 1 over q equals 1 over b. And we are solving for b. Okay, so we're going to, just like with the other problem, we want to multiply the entire equation by the least common denominator. So for this one, we have 3 different denominators. They're just single terms, so the least common denominator will include all those terms. So I'm just going to say R, Q, B. That's the least common denominator. And what order that you write those letters totally doesn't matter. So we're going to multiply everything by RQB. 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 Okay, so let's be careful because all these letters can get, confusing. So in the first rational, the R's cancel out. So all I have left is QB. In the second rational, the Q's cancel out, and I just have plus RB equals, and in the third rational, the B's cancel out, and I just have RQ. Okay, so we are trying to solve for B. So your goal is to get all the terms that have B on one side of the equal sign. And then once you have them on one side, then you can factor out B to start getting B completely by itself. So we actually already have all the terms with B on the left side of the equation. So let's factor out B. So if we factor out a B, that's like dividing everything by B, basically, to figure out what's in the parentheses. So we would have Q plus R in the parentheses when we factor out B. All right, and now to get B by itself, it's B times Q plus R. So let's divide by Q plus R on both sides so that these will cancel out. I'll just have that B equals, which is my goal, RQ over Q plus R. Okay, So let's look at how we would enter that into the test. Again, MyMathLab is helpful because it reads the math, so it knows, like if you were to type QR, it knows the same thing, it's RQ. So let me write down what that is, because I have a bad memory. RQ over Q plus R. Okay, so RQ, all of that, divided by Q plus R, or if you said R plus Q, that would be correct as well. All right? Okay. Number 9. A pool can be filled by one pipe in 6 hours and a second pipe in 2 hours. How long will it take both pipes to fill the pool? I'm going to just use this screen. I think the problems that don't require a ton of writing, I'm going to just use this screen and try to write as neat as possible, but the ones that are a lot of writing, I'll go to the Paint app. I just write better on that particular one. Okay, so the way we're going to solve this is this way. So a pool can be filled by one pipe in 6 hours. So that means that it can fill 1/6 of the pool in 1 hour. Plus second pipe in 2 hours. So plus it can fill, the second pipe fills the pool, 1/2 of the pool in 1 hour. So basically, guys, you're going to do 1/6 because it fills it in 6 hours, plus in 2 hours you'll do 1/2 equals, you're trying to see how long it'll take for them to both together fill the pool. So we're going to say plus equals 1/, I like to use T because it's always asking for, okay, I hope this idea works. It's always asking for together. So again, 1/6 because the first thing can be completed in 6 hours, plus 1/2 because the second can be completed in 2 hours. How long will it take them to do it together? Add them together, and they should equal 1/T. I use T to represent together. So we're going to multiply the entire equation by the least common denominator. So we have a 6, a 2, and a T. So in our least common denominator, this is making my skin crawl. It looks so bad. Okay, least common denominator, we need to definitely have a T in there. And now 6 and 2. So if you could multiply 6 times 2 and get a common denominator. And you could use 12. But it's best to use the least common one because that means you have very little reducing to do in the end. So what's the smallest multiple 6 and 2 both have in common? Well, that's actually 6. So the LCD is 6T. So let's multiply everything by 6T. This is when you wish you had an iPad because it would look better. Okay, anyway, so here we go. Now, 6T times 1/6, the 6's cancel out, and we'll just have 1 times T, which is T. Then here, plus 6/2 reduces to 3, so we have 3T, and then that equals 6T times 1/T, the T's cancel, and we just have 6. So T plus 3T equals 6. T plus 3T is 4T equals 6. To solve for T, we'll divide by 4. And so t equals 6 divided by 4. Now it's asking you to write your answer as an integer, which would be a whole, positive or negative number, or a decimal rounded to the nearest tenth. So remember, you can use a graphing calculator on this test. So 6 divided by 4 is actually just 1.5, and that is already rounded to the nearest tenth. So 1.5 would be your answer. So together, they can fill the pool in about 1.5 hours. All right. Okay. I do not like using that pen, but I'm going to use it here because it's a little easier for this problem. Okay, so now this is number 10. Determine whether the relation is a function, then give the domain and range of the relation. Let me make this a little bigger. Okay, so we've got the set here of ordered pairs of points. Okay, so 6, 8, 6, 9, and 6, 10. So the domain is all of your possible x values, and the range is all of your possible y values. So if we look at all of our x values here, so we've got 6, 6, and 6. So the domain is just simply 6. All right? It's just one number. You don't have to list them multiple times. The range would be all of the possible y values. So that would be 8, 9, and 10. Now, is it a function? So a relation is a function if each x value corresponds to exactly one y value. So right now, 6 is corresponding to 8, 9, and 10. Basically, for it to be a function, you don't want the x values to repeat. So your x values are definitely repeating, so that would be a no. Okay? The answer would be no here. And then if we check our answer, we're good to go. All right? Okay. All right. Find the indicated function values for the function below. So I'm definitely going to do that on Paint because I'm going to have to do a little more writing. So let me write all of these down. For these type of problems, there's not a way for me to take out problems. So these can get kind of long, but you do get partial credit for problems like this. Okay. So we have h of x equals 6x squared plus 5. Okay, so the first one we want to find h of 0. So this is function notation. That just means I'm going to plug in 0 everywhere I see x. So I have 6 times 0 squared plus 5. So we have to use order of operations just to remind you. PEMDAS, or please excuse my dear Aunt Sally. So that means that so parentheses means if there's anything to reduce in the parentheses. The only thing here is a 0. There's nothing to do. So the next thing to do is to take care of your exponents. So 0 to the second power is just 0. That's going to be 6 times 0 plus 5. Then next is multiplication or division. So we would do 6 times 0, which is 0, plus 5, which equals 5. So that first answer is 5. Okay, the next one, h of negative 1. So we're going to plug in negative 1 in for x. So same thing, we're going to do that exponent first. So negative 1 to the second is negative 1 times negative 1, which is positive 1. So we have 6 times positive 1 plus 5. That's going to be 6 plus 5, which equals 11. Okay, h of 2, we're going to plug in 2 everywhere we see an x. So again, doing the exponent first. So we have 6 times 2 squared, which is 4. 6 times 4 plus 5, which will give me 24 plus 5, which is 29. Okay, h of negative 2, which would be 6 times negative 2 squared plus 5. Okay, negative 2 squared is negative 2 times negative 2, which is positive 4. So this problem, I'm trying to see if you're going to catch that. Some people would say negative 4, and they would end up with the wrong answer. So the negative 6 times 4, again, 24 plus 5, which equals 29. And then now h of 4b. So we're plugging in 4b everywhere we see x. Okay? So now, same thing. Let's take care of the exponent first. So 4b quantity squared is going to be 4 squared is 16. B squared is b squared. So 6 times 16b squared plus 5. So now we're going to multiply 6 times 16, which is 96 b squared plus 5. And then we can't combine that further because they're not like terms. So that's going to be our answer. Okay? So if I went fast, you may have to go back and watch that because I'm taking a little longer. Okay, so I've got 5, 11, 29, 29, and 96b squared plus 5. Drum roll, please. Yay! Okay. Okay, so use the vertical line test to determine if y is a function of x in the given graph. So when you have these graphs, if you press this zoom in, it makes it a lot bigger for you if that helps you to look at it. Okay, so the vertical line test just simply means if you can take a vertical line, which is a line drawn straight up and down, and if you draw that line somewhere and it crosses the graph more than once, that means it fails the vertical line test, so it was not a function. So as you can see here, here's somewhere where it fails the vertical line test because it's crossing it here and here at the same time on that same vertical line. So this means that no, this graph, this relation, is not a function. So that's what the vertical line test means. So this was not a function. And you can see it right here as well. It fails the vertical line test. So that's a no. Okay. All right. All right. So find the domain and range of the relation. Okay. So let's focus on the domain. So the answer choices here, let me just explain the answer choices. So they're trying to say, okay, the domain, infinitely many points within a certain interval of numbers. Or B is saying, is a domain a list of distinct numbers? Like if it was a bunch of points, then list all of the x coordinates of the points. That would be for B. A would be the answer for this problem, but it then asks you, okay, now tell me what the domain actually is. So let me make this bigger. All right. Okay, I want to move this. Okay, so remember that the domain is talking about all of your possible x values. So let's see your graph here. So your x values, this is your x-axis there. So from left to right, what is my graph doing? So if I start at the left, it's starting at what x value? At 2. And it's a point on x equals 2, so we're going to use a bracket to say it's beginning at 2, and then it's going on and on and on and on and on to infinity. It's no stopping point. So it's going to be bracket 2 all the way to infinity. That's going to be your domain. Now let's talk about the range. Let's use red. Okay. I want red. Okay. All right, so the range is talking about all of your possible y values. Okay, so this is your y-axis, and that is going from the bottom to the top. Starting from the bottom and going to the top, it's starting at what y value? -5. And the point is at y equals -5. So we're going to start with a bracket at -5. And now what is the graph doing? It's going upwards continually. All right? So it's going, so like if we were to keep going, it's going to get taller and taller and bigger. So your range is going from -5 all the way to infinity. Okay? All right, so that's your domain and that is your range. Wait, I don't want the pen. Oh, jeez. Okay. I failed. Hold on. Great. Hold on one sec. There we go. Okay. So, let's put that answer in there. So make that graph bigger. It'll probably help you see it better. That would definitely be smart to do. I'm sorry, my writing looks crazy. Okay, so the first answer choice, the domain is an infinite number of points within an interval, within a region. And it's starting at 2, parentheses, and there's an infinity button here. Just need 1, and then you always use parentheses by infinity. And then for the range, it's also infinite points within an interval. So it's starting with a bracket at -5, and it's going to infinity with parentheses. All right? Okie doke. All right, the next one, find the domain of the function. X plus 12/6 minus x. So you want to check for denominators. And so here we have a denominator that has a variable. That first x does not affect our domain because that's not in a denominator. All right? So what we want to do let me make this smaller. Hold on. Well, I was going to make it smaller, but it's being difficult, so we'll just do it here. Okay, so the function was g of x equals x plus 12/6 minus x. Okay, so we're trying to find the domain. The domain is based on what I just circled in green. So anywhere where 6 minus x equals 0, we want to exclude from the domain. So let's solve for x and see what value we want to exclude. So negative x equals negative 6. So then that means that if we divide or multiply by negative 1, x equals positive 6. So we want to exclude that value from the domain. So if we were to think about that on a number line, the domain would be all of the real numbers, all of them. So if I wanted to shade all of them, I would say it's all the way from negative infinity all the way to positive infinity. But I got to exclude x equals 6. Let's just pop him in the middle. Let's make a little space here. We're going to just pop that bad boy right there. And we don't want to include this, so we're going to use an open circle. So we're going to say everything except right here. Okay? So that's what the graph would look like. It'd be like a big hole at 6, and we would include everything except for x equals 6. So to write that in interval notation, let's see. So we always go left to right. So we would start with negative infinity, and we would go all the way to 6. But we're not including 6, so we're going to use parentheses. So just to make sure you see my color, this in red is that first interval. Okay? Now, the second one, let's use blue, is starting from 6 to infinity. Because you always go left to right. So parentheses 6 all the way to infinity. All right? And then 1. Okay, and they use the word or, just so you know what word they're using. So they're saying that your answer would be, your x value, possible x values could be in this first interval or in this second interval. So this would be your domain of this function. All right? Because we are excluding x equals 6. Okay? So that would be A. Okay? All right. So find the indicated function values below. Let me write this out. G of x equals negative the third root of 64x minus 64. We're going to find g of 2, g of 1, and g of 0. Okay. So g of x was negative the third root of 64x minus 64. So we're going to find g of 2 first. So everywhere we see x, we're going to plug in 2. So 64 times 2 is going to give me 128. So 128 minus 64 is going to be 64. So negative times the third root of 64. So you can use your graphing calculator to find the third root of 64, or it would be great if you know your perfect cubes by heart. But the third root of 64 is 4, because 4 to the third power is 64. So it's going to be negative 4, because this 4 came from this, and then we apply the negative. The answer of g of 2 is negative 4. And the next one was g of 1. So we have negative times the third root of 64 times 1 minus 64. 64 times 64. So 64 minus 64 is 0. And the third root of 0 is just 0. negative times 0 is just 0. So g of 1 is 0. G of 2 is negative 4. And then g of 0. So we're going to plug in 0 everywhere we see x. So 64 times 0 is 0. 0 minus 64 is negative 64. Now, you can take the third root or the odd root of a negative number. It's going to give you a negative answer. So negative times the third root of negative 64 is negative 4. And then negative times negative 4 is just positive 4. Okay? Okay. So let's put those answers in. Negative 4, 0. If you don't know, tab takes you to the next answer choice. I like to know the little hints to do these type of things a little quicker. Okay, so use radical notation to write the following expression. 27 raised to the 2 over 3. 27 raised to the 2/3. Okay, so let me zoom in a bit here. Something to remember. So when you are, let me go to my pen. Okay, so when you're going from rational exponent to radical notation, so the bottom number is your root number or your index number. And the way that I remember that is that root, bottom of the graph. And then the top number or the top number or the higher number in the fraction is your power. And then how do I remember that? Another non-math way, higher power, higher number in terms of position. Okay, so to rewrite this, this would be, oh, I didn't want to do that. Oh well. Can I undo? No. Okay, so this would be the third root of 27, and the power, all of that raised to the second power. Because again, the bottom number is your root, and the top number is your power. So that would be radical notation. That is what you're going to type in the first box. All right. So I need to make this smaller so I can actually see what I'm doing. Maybe not that small. Okay. So I'm just going to actually type that in. So if you look here, this is what we would use to do any root that's not square root. All right. So I want this one. So I have a spot to put the third root of 27. And then all of that I want to put in parentheses. So I'm going to put all that in parentheses. And then all of that is being raised to the second power. And then now to simplify, we're going to just actually work that out. So you're going to do the parentheses first. So the third root of 27 is 3. And then we're doing 3 squared, which of course equals 9. So your simplified answer would just be 9. All right? So you're going to do two different things here. The first one, radical notation, is just what I typed here. And then simplify is to actually simplify. Do what it says. Okay, multiply and simplify. I'm going to do that in my Paint applications. So give me a second to write that down. The third root of 36x to the 4th y squared times the third root of 6x y to the 6th. Okay. So I have the third root of 36 x to the fourth y squared times the third root of 6x y to the sixth. Okay, so if you have the same radical, so they're both third roots, you can multiply them together. So let's just make one big radical and then simplify it from there. So 36 times 6 is 216. X to the fourth times x, add the exponents, that's x to the fifth. Y squared times y to the sixth will be y to the eighth. You add the exponents. Okay, so you may want to check and see if 216 is a perfect third, just to see. So if you take the third root of 216, you get 6, because 6 to the third, so the third root of 216 is actually 6, because 6 to the third equals 216. So we can simplify this part and just go ahead and say that equals 6. So now under the third root, we still have that x to the fifth, y to the eighth. Okay, so let me do it the long way. So the long version, I'll do it for the third root of x to the fifth. So that means we have 5 x's under the radical. 1, 2, 3, 4, 5. We're looking for the third root, so we're looking for groups of 3. So there's 3. So I'm going to take, if I write that x on the outside, that represents that group. And we don't have any more groups of 3 under that third root. So whatever's left over stays under the radical. So your answer would be x times the third root of x squared. Now here's the short version. This is the one I prefer. Okay, so it's the third root of x to the fifth. I like to use division. So I say, okay, 3 goes into 5 how many times? So 3 goes into 5 one time. So x to the first would be on the outside, because 5 divided by 3 is 1, and then there's a remainder. So x to the 5 over 3. See, we wrote that into radical form. We went from radical form to rational form. So now 5 divided by 3, that is 1 plus a remainder of 2, right? So what that means is this remainder of 2 would be what's under the radical still, x squared. That's what would be under the radical. Now, I don't write all of this in purple. I just think to myself, okay, 3 goes into 5 how many times? 1 time. That's that x to the first on the outside. And then with how many remaining? 2 left over, so that is what's under the radical. So let's do it for the next one. So let me write down what we have first. So I have 6. Now I have that x on the outside because that's from this x here. And then I have x squared still under that third root. Now I'm going to take care of that 8, y to the 8th. So now 3 goes into 8 how many times? 2 times. So y squared will come out of the radical with how many remaining? 2. So y squared would be under the radical. So this was still there, and then 6x was still here. And so that's going to be your final answer. So it may help to just do it in pieces like I just did here. So let me kind of summarize this together for you. Not that small. Okay, whatever. All right, so I started off by just multiplying the 2 radicals together. And then I took care of the third root of 216, which is 6. And then I took care of the third root of x to the 5th, which is x times the third root of x squared. And then I took care of the third root of 8, the third root of y to the 8th. 3 goes into 8 2 times with a remainder of 2. So that's why we have y squared on the outside. That's that 3 goes into 8 2 times. And then the remainder of 2 is the y squared on the inside of the radical. So this will be your final answer here. Okay? I need to write that down so I can type that in. Okay, so let's type that in. So I've got 6xy to the second. Now I want the third root. So pay attention. You don't want to pick the square root. This is not a square root. This is the third root. So we're going to press that, mark that as the third root of x squared y squared. And that's our answer there. So just be really careful with how you enter your answers. It's also helpful to write down your work. So if you think that you didn't input your answers how you wrote the answers, make sure you write good notes and turn that into the testing center. But you need to alert me and let me know if you think that's what happened, and I'll go through and check your work. All right, so the next one, the third root of 81x to the fourth minus the third root of 375x. Okay, so we are subtracting radicals, so in order to combine when you are subtracting radicals, you must have not only the same radical, but also the same radicand, what's underneath the radical sign. So we have the third root of 81x to the fourth minus the third root of 375x. Okay, so we can't combine this just because of them both being the third root. We have to be the third root and have the same thing under that third root. So let's see if 81 is a perfect cube. And it is not. If you do the third root of 81, you get 4.326 blah, blah, blah. So that means it's not a perfect cube. So we're going to use a factor tree to start to reduce it. So let's do that here on the side. So the third root of 81. So if I think of two numbers that multiply to give me 81, I can start with 9. Because 9 times 9 is 81. Now if I continue with my factor tree, so I'm looking for 3 of the same kind. So here's a group of 3s. I need 3 of the same kind. So that's going to be that on the outside. And then what's left over is this 1, 3 stays under the radical. All right. So now let's look at the the variables. So 3 goes into 4. 3 goes into 4 one time with an x left over under the radical. So let's take care of the 81 part. So the third root of 81 is 3 times the third root of 3. So there it is there. And then the third root of x to the fourth is what we have in blue. So basically it's 3x times the third root of 3x. Okay? So now let's take the third root of 375. That gives you a decimal, so that means we're going to use a factor tree to reduce the third root of 375. So you want to think of two numbers that multiply to give you 375. So that would be 75 and 5 is a good start. Let's see, 25 and 5, no, 3. Not 25 and 5, 25 and 3. And then 5 and 5. So this is the third root, so we're looking of 3 of a kind. There's 1, 2, 3. So that would be a 5 outside of the radical. And what's left over will be this 3 here. So the third root of 375 is 5 times the, wait, let me put that up here. 5 times the third root of 3. And so now we have this x under the radical. 3 cannot go into 1. This has an exponent of 1, so that x is just going to stay under that radical. So we basically have 3x times the third root of 3x minus 5 times the third root of 3x. And remember I said you can't combine radicals unless they have the same radical, same index number, and the same thing under the radical, which these now have. So we can just combine the outside now. So 3x minus 5 is what's outside of the radical, and we are combining like radicals, so it's going to be 3x minus 5 times the third root of 3x. All right? And that would be your final answer. You want to put 3x minus 5 in parentheses because all of that is being multiplied by third root of 3x. If you just type 3x minus 5 and then the third root of 3x, it looks like it's just multiplying that negative 5 times the third root. But you want to multiply the entire expression, 3x minus 5, times that third root. Okay. (3x minus 5). Then go to that nth root option and type the third root of 3x. All right. Okay. 19. So we're going to rationalize the denominator. And I'm running out of time for you guys, so I'm going to probably go a little faster than you would like, but this will be posted very shortly, as soon as the program finishes downloading it. Okay, so we have 3 divided by the square root of 2 minus 6. So to rationalize the denominator, we're going to multiply by what's called the conjugate. So the square root of 2 plus 6 over the square root of 2 plus 6. So now at the top, we have 3 times the square root of 2 plus 6. And on the bottom, we have the square root of 2 minus 6 times the square root of 2 plus 6. So at the top, we're going to distribute the 3. So 3 times root 2 plus 3 times 6. That'll be 3 root 2 plus 18 over. And the bottom we're going to FOIL. First, outer, inner, and last, which is just the distributive property. So first, root 2 times root 2 is root 4, which is going to be 2. I'm just going to write it out. Outer plus 6 root 2, inner minus 6 root 2, and last minus 36. And the reason why we're doing this is that you don't want a radical in the denominator. So now we have 3 root 2 plus 18. In the bottom, 6 root 2 minus 6 root 2 cancels out. The square root of 4 is 2. And then we have minus 36. So the radicals are now gone in the bottom. I just have negative 34. And at the top, I have 3 root 2 plus 18. And if there were a way to simplify 3, 18, and 34 by a common factor, then we would. But since there's not, we can leave this as our final answer. Okay. I'm going fast. This is where mistakes are made. So let's see if I did. That's why I always say take your time. Let's see. I want to divide all of that by by negative 34. Yay! Okay. The next one, we're going to solve this radical equation. So I have the square root of 5x minus 9 equals 0. Okay, so the goal is to get x by itself, but first we want to get the square root by itself. So we're going to add 9 from there. So then I'm going to have the square root of 5x minus 9 equals 0 plus 9 is 9. Now I'm ready to get rid of that square root because I can't add 9 again because that's underneath the square root. So I got to get rid of that square root first to then get rid of that minus 9. So powers undo roots. So to get rid of a square root, I want a square power. But I have to do it to both sides of the equal sign. So that's going to cancel out the radical. So on the left I have 5x minus 9 equals, on the right, 9 squared is 81. Okay, now I can start to get x by itself. So I'm going to add this 9 to get the term with x by itself. So 5x equals 90. And now I can divide by 5 to get x completely by itself. So x equals 90 divided by 5, which is going to be 18. So x equals 18. All right. Okay. 21. Subtract as indicated. So I have now complex numbers here. The last few problems are going to involve complex numbers. And you treat them just like you would variables, except you want to remember that I actually represents a value, like a number. But in terms of adding and subtracting, you treat it just like you would a variable. So we have 5 minus 3i minus 4 plus 2i. So just like you would if you had x's in here, we want to distribute this negative. So we're going to rewrite the first expression, 5 minus 3i, because the parentheses aren't needed there. And that's going to be negative 4 minus 2i. And now we're going to combine like terms, just like you would if they were x's or y's. So 5 minus 4 is 1, and then negative 3y minus 2i is negative 5i. So that's going to be your final answer. 1 minus 5i. Okay. All right, 22, you were multiplying two binomials that have complex numbers, but you're going to multiply them like you would any binomials. So we had negative 6 plus 2i times negative 6 minus 2i. And if you look here, you actually have conjugates here. So let's see what happens when you multiply conjugates with complex numbers. So if we FOIL, first times first, negative 6 times negative 6, outer, negative 6 times negative 2i, inner, positive 2i times negative 6, and then last, positive 2i times negative 2i. So negative 6 times negative 6 is positive 36. Negative 6 times negative 2i is positive 12i. 2i times negative 6 is negative 12i. And then 2i times negative 2i is negative 4i squared. So when you're dealing with complex numbers, whenever you see I squared, that equals negative 1. So don't forget that from that section, because the reason why is I equals the square root of negative 1. And if you square I, you get the square root of negative 1 squared, which is just negative 1. This is the important thing you want to really remember when you are multiplying, dividing, things like that with complex numbers. As soon as you see an I squared, immediately change it to negative 1. So negative 4i squared is actually negative 4 times negative 1. Okay? So we have 36. 12i minus 12i cancels out. And then negative 4 times negative 1 is actually positive 4. So we have 36 plus 4, which is going to give me 40. But this is super, super important, this I squared equals negative 1. So as soon as you see I squared, immediately swap that out for negative 1. And you're multiplying, okay? Here you are multiplying. So when you swipe it out, don't say that's negative 4 plus, minus 1. That's negative 4 times negative 1, because it's negative 4 times I squared. So the answer here would be 40. Okay. All right, so divide and simplify to the form a plus bi. So you're going to, just like for the other one, we want to rationalize the denominator, because you don't want radicals in the denominator. Well, you don't want complex numbers in the denominator as well. So let's see what we will do. So you're going to multiply by the conjugate here, just like you did for the radicals. So we have 52i divided by 5 plus I. So we're going to multiply the top and bottom by the conjugate of 5 plus I, which is 5 minus I. Okay, so we're going to have 52i times 5 minus I over 5 plus I times 5 minus I. So at the top part, we have 52i times 5 is going to be 104i. And then 52i times negative I is negative 52i squared. Then on the bottom, 5 times 5 is 25. 5 times negative I is negative 5i. I times 5 is positive 5i. Then I times negative I is negative I squared. Don't forget, I squared equals negative 1. 52 times, I gotta chat, let me see. Oh, I did 52 times 2. Thanks, guys. Thanks for catching me. So 52 times 5, yes, is 260. Good catch. Thank you, thank you, thank you. So 52i times 5. See? Rushing. All right, 52 times I is 260i. So let me fix that here. Okay. Thank you much. There we go. Okay, cool. All right, so don't forget, I squared equals negative 1. So as soon as you see an I squared, swap it out with negative 1. So that's actually 260i minus 52 times negative 1 over negative 5i plus 5i cancels, and I have 25 minus times negative 1. All right, so now we've got 260i plus 52 over 25 plus 1, which is 260I plus 52 over 26. Now, you do want to simplify, so these are all even numbers that can be divided definitely by 2. So let's see if we can simplify. And the thing is, when you simplify this, this is all over 26. So it's like saying 260I over 26 plus 52 over 26. All right. So if you want, you can put 260 divided by 26, which gives you 10. So that's 10I. Not if you want, you do that. And then plus 52 divided by 26 is 2. Doesn't always happen nice and pretty like that, but it does sometimes. Sometimes it may simplify to a reduced fraction. So, and then we want to use the form A plus BI, although I don't think MyMathLab cares if you put it in this form, but let's just put it in A plus BI form. So it'll be 2 plus 10I. And the reason we had to reduce is because it tells you to simplify. 2 plus 10I. Okay. Yeah, simplify your answer. So 2 plus 10I. And there we go. There. Okay. So now here, 13 plus 4I over negative 8I. We want to rationalize that denominator as well, but it's not, let me write down first. 13 plus 4I, oh, that's ugly, over negative 8I. Okay, so to rationalize the denominator here, we multiply the top and bottom by, so here's the deal. Your book and a lot of books tell you to multiply by the denominator. You can absolutely do that, but the goal is really to just get rid of I. So you really and truly could just multiply the top and bottom by I, and that'll get you the same answer. So I'm going to do that because that's a little quicker. So we are multiplying the numerator by I, 13 plus 4I times I over negative 8I times I. So at the top, we're going to have 13I plus 4I squared over, in the bottom, negative 8I squared. But remember, I squared has to be swapped to negative 1. So I got I squared here and I squared there. So it's 13I plus 4 times negative 1. And if you want, if you notice what's happening, it's basically changing your signs, right? So if you can start to see that pattern, even better. So what's going to be now is 13I minus 4 divided by positive 8. Now you can't reduce everything by a number, so I am pretty sure MyMathLab will take that. No, actually I don't think it will. Let's see. I think it's going to want you to simplify it because it wants you to put it in that form. Negative 4 plus 13I. Pretty sure it's not going to like that. Yeah, it didn't. Okay, so let's simplify this. So let me go back here. All right. So remember I said you want to simplify it and write it into this form, A plus BI. So first off, let's make that negative 4 plus 13I over 8. Now, let's separate it. So that's going to be negative 4 over 8 plus 13I over 8. So negative 4 over 8 is negative 1/2. Then 13I over 8, that can't be reduced any further. So it should accept this answer. So let me write that down. Okay. Negative 1/2 plus 13i over 8. Drum roll. Woohoo! Yeah. So you have to put it in simplified form. Sometimes the denominator can be divided into everything in the numerator, and sometimes you have to split it up and simplify it separately. Just kind of depends on what the numbers are. So it may help to just split it up and then simplify from there, and whether you simplify both or just one, care of itself. Then finally, negative I to the 16th. All right. Okay, so negative I to the 16th. So you're like, there's not a button like that in your calculator. So it's helpful to know some of your more basic I higher powers. So like I to the first is just I. I squared is negative 1. I to the third, what would that be? So that would be, if we thought about it, I to the third is the same thing as I times I squared. And so I squared is negative 1, so that's like saying I times negative 1. So I to the third is actually negative I. What about I to the fourth? Well, I to the fourth, you can think about that as I squared times I squared, which is going to be negative 1 times negative 1, which is just 1. And it helps to kind of know, be able to do it up through maybe I to the 8th. But what's neat about this is that there's a pattern here. So this pattern that you see here, it just repeats. So I to the 5th would be the same thing as saying I to the 4th times I, which would be 1 times I, which is just I. And look at your pattern. What's after I? Negative 1. What's after negative 1? Negative I. What's after negative I? 1. And if I were to keep this going, I to the 9th would be, what do you think? I. So the pattern just continues on. So if you can remember the very first 4, you can keep going, actually. But I wouldn't suggest for you to go all the way to 16, right? So if you use one of your lower powers that we have here and rewrite this, you can start to get the answer. So first off, I to the third. Okay, first off, we have negative I. We got to change this negative I into something that we can use to get to our answer. So I would go with negative I is I to the third. So I would switch this out to say I to the third raised to the 16th. All right? So 3 times 16 is 48. That's actually I to the 48. So you're probably looking at me like, what in the world, right? So you could think this a few different ways. You could look at your powers that you have here and use them to rewrite 48. So like 48, I don't know, 48 is equal to 8 times 6, right? So if you change this to maybe a to the 6th raised to the 8th, for example, that would equal I to the 48th. And so why am I doing that? Well, I know what I to the 6th equals. I to the 6th is negative 1. So I can say that's negative 1 raised to the 8th. And I know what negative 1 raised to the 8th is. Negative 1 raised to a positive exponent is going to give me positive 1. And you could have done that a few other ways. You could have said okay, I to the 48. Well, I know that, 24? Yeah, 24 times 2 is 48. So you could have said I squared raised to the 24th, for example. And you could have done that because you happen to know that I squared is -1. So then you could have said, oh, okay, that is -1 to the 24th. And I know that -1 raised to an even power is going to give me +1. And then, so you could have gotten it a few different ways, but the key thing is knowing like these first 8. And really, if you know the first 4 and you know the pattern, you can just keep going from there. But long story short, the answer here is +1. And so, let us hope. And we're good. Okay, so now I did go through this with, tech issues and whatever, but just in case this takes longer than I thought, I'm going to extend the time on this just because. So I'm going to give you, this is way too much time, but I'm fair and I want y'all to be successful. I'm going to give you 3 hours for this because I'm a little nervous about the time. So I'm going to, I just put the referral in a few days ago. I'm going to put a new one in to say that it's 3 hours. I don't think it'll take you that long, but if it does, that's fine. But I'm going to change it to 3 hours to do the test, just in case this is a little longer than I thought. But that is the review. So you can use your graphing calculator when you do this test, as well as all of your others. All of the content, the quizzes are due on Wednesday. And what I have the homework, honestly, guys, it's been open the whole time. So the homework's kind of been open all semester. The quizzes have due dates. You can actually do the quizzes after the due dates, but you get a slight deduction on your grade after the due date. So that's available. If you went to the math fair, hopefully some of you did go and had a good time. Be sure and submit your attendance using the information on the assignment posted in Blackboard. Okay, cool. Woohoo, we got an A, guys. Be sure and submit your attendance verifications. I can give you extra credit for that. I am updating grades now as we speak. If you have any questions at all as you prepare for your test, please don't hesitate to contact me. Come to the depot. Use your smart thinking. And then there's going to be some final exam reviews coming up for the campus that you're welcome to attend. And then we'll have our usual session. I'll have the date and time sent out within the next week, so you can plan for that. So if there's no other question, any questions at all, y'all can type them or yell them to me. Okay, thanks so much for working with me today. I know we went over time, but I'm going to add some time to your test just in case. And yeah, enjoy your weekend, study hard, don't stress out. You guys are doing great. And I will be on email if you need me. Take care. Bye.